I'm Jeevan from TE08, and today I'll be doing an experiment demonstrating Newton's second law. For this experiment, we'll be using flour, 2 apples, 2 bottles, one empty, one filled, a metal ball, and a ruler. So for the first experiment, we'll be using 2 apples. They are the same mass, 0.2 kg. I'll be dropping them from the same height. Okay, I'll be dropping them in 3, 2, 1. As you can see, they create the same depth. The force, which in this case is the weight that's pulling them down, is the same as their mass is the same. The speed of the apples are the same as well, causing the acceleration to be the same, which is why the force exerted on the flour is the same. For the second demonstration, we are going to be using 2 bottles, one's half filled and one's empty. Obviously, the bottle which is half filled has more mass than the one that is empty. So we will see what happens when we drop both of them from the same height. I'll be dropping them in 3, 2, 1. As you can see, the bottle which has larger mass created more depth, and the bottle which was empty created lesser depth than the one with more mass. This is because when the mass of an object is larger than the other one, it has a larger downwards force causing more depth. For the third demonstration, we're going to be using flour, a 30 cm ruler, 3 metal balls of the same mass, and for this demonstration, we're going to be measuring 3 different heights, 5 cm, 10 cm and 30 cm. And we're going to be dropping the 3 different balls from 3 different heights. And we're going to be seeing what's the difference in depth from dropping from different heights. So firstly, we're going to be starting off with the 5 cm mark. So 5 cm and drop. Secondly, we're going to be doing 10 cm, drop. And lastly, we're going to be doing 30 cm and drop. As you can see, the depth of the 30 cm height is so much more compared to the other two. While the 5 cm and 10 cm are pretty close to each other, but you can clearly see that 10 cm it is deeper than the 5 cm mark. In this demonstration, we can see from this demonstration that a 30 cm ball drop had a higher acceleration than 10 cm and 5 cm. This is because the depth of the 30 cm ball was much more larger than the 10 cm and 5 cm. So for this demonstration, we can say that the force exerted on the flour, it is directly proportional to acceleration. So the higher the ball drop, the higher the acceleration, the more force applied on the flour. Okay, to sum things up, we'll be using the F equals to ma formula. F stands for force, m stands for mass, and a stands for acceleration. So for the first demonstration where we use 2 apples of the same mass, we can say that the force is directly proportional to the mass, as when we drop the 2 apples from the same height, they created the same depth, which shows in this case the force exerted on the flour, which is their weight, was exactly the same because of the similar mass of both the apples. Okay, for the 2 bottle demonstration, which had 1 bottle which was half filled and 1 which was empty, we can clearly see that the mass of one of the bottles is larger than the empty bottle. So for this experiment, we can say that when the mass is larger, the force exerted on the flour is larger, as we saw that when we dropped the bottle with larger mass, there was a deeper depth, and when we dropped the bottle which was empty, there was lesser depth than the one with larger mass. For the third demonstration, which we used the 3 metal balls with the same mass, the mass was constant. So for this demonstration, we can say when the height is at 30 cm mark, the acceleration was higher than the 5 cm mark and the 10 cm mark, causing the depth to be larger. And from that, we can conclude that the force is directly proportional to the acceleration when mass is constant, which is why when we dropped it from a higher level, the acceleration was higher and the depth was larger. Okay, so that's the end of my experiment and demonstration of Newton's second law. I hope you had a better understanding of Newton's second law and the formula F equals to ma, and the relationship between these 3 properties: force, mass and acceleration. Thank you.